we have a relationship with this company. So the journey has started. Even after this training, if we have any issues, I hope that we can continue to consult you. We are not all novices here. We have mathematicians, we have sociologists, we have people from statistics that will do hand-holding as you are taking us through. So we are not all novices. This university is well equipped with human resources. So thank you so much, everyone. We are most welcome.
Thank you very much, Mama, for that welcome speech. I just asked the director of SPSS welcoming our visitors, the Dean of School of Environmental Studies just walked in the person of Professor Chidi Jogo. Sir, you're welcome. We welcome you. So you can see the cloud is gathering. Before, in the next 30 minutes, I think the hall will be filled. And you have a full class. Next on the program is the opening remark and goodwill message from the Vice Chancellor, Professor Nina Namaya Oti. She is ably represented this morning by the Director of SPSS, Professor Gloria Chidebe. There you go.
Distinguished professors and participants, distinguished resource persons, Professor Paul, good morning from Nigeria. On behalf of the Vice Chancellor, I most respectfully welcome you all to this workshop. Our Vice Chancellor is a well-known name worldwide. She's the Amazon mother of Nigeria. Before that title came about, she was one time Dean of PD School. And we all know the reforms she introduced on PG research when she was Dean. She achieved a lot. Many students graduated with genuine PG research results. On her own person, her PhD, there was a time things were very hard in this Nigeria. Academics were so discouraged working. The NUC requested all vice chancellors to select their good PhD theses and send to Abuja. And her own was selected. And they found her worthy. And they sent her to the United States to do whatever bench work she needed to do. Thank you. But that clap is not enough. The Vice Chancellor, Professor Noti, followed the crowd. People are discouraged. Just went out there, cooked results, copied other theses. Would her work have been selected? Because the trend is that a lot of people feel there's no need, nobody is even reading this thing. Just go, they are passing. No need to read it. Supervisors may not read, external examiners may just browse through and pass. We want to put a stop to that. Because we have seen what research results is doing all over the world. and we are also a beneficiary. That exposure, I'm sure it gave impetus to our Vice Chancellor today. And I'm going to US, how many of us, well, the professor's salary was less than 10,000 naira. Maybe she was just a senior lecturer and she was sent to US. You understand? So I want us to genuinely, I'm telling you now on behalf of the Vice Chancellor, because that is what she stands for. Supervise the research with all your heart and all your mind so that you get a result. Companies can come up from research results. Yes, companies can come up from research results. And also, I want to also let us know that there are billions of dollars out there for research, grants that we are not being part of. If you understand how to use these statistical methods, you apply for any of these grants, you get it, you deliver. Once you deliver one, any other one you apply for, they will give you. And there will be multiple sources of income. You won't rely on this our peanut professor's salary. You will even beg the university to allow you to retire. Am I not correct? So on this note, on behalf of our amiable Vice Chancellor, I want to declare this workshop open.
Thank you. The Amazon of the new modern Nigeria. Can we give her a round of applause for her? On the program is our target welcome address to the workshop by the facilitator and the director of the institute, Dr. Mohammed Yusuf. Is he present? Can we give him a round of applause? Good morning, my Prof. I'm director of the center. Other directors here present. My distinguished professors here present. And my colleagues. I will not say ladies and gentlemen because you are also colleagues. I'm also a lecturer at the Federal University of Katsina State. I'm also a member of CIB and also a facilitator. That is the reason why I'm here to take the welcome address on behalf of the Institute. A workshop on statistical methods in research organized by the Center for Excellence in Sustainable Procurement, Environment, and Social Standards, in conjunction with White Knights Consulting and Center Certified Institute of Business Entrepreneur for staffs of Federal University of Technology, Owerri. Distinguished guests, esteemed facilitators and participants, it is with great pleasure that I welcome you all to this highly insightful workshop on statistical method in research, organized by the Center for Excellence in Sustainable Procurement, Environmental and Social Standards, facilitated by Certified Institute of Business Entrepreneur, CIBE, in collaboration with White Knight Consulting for the staffs of Federal University of Technology, Owerri. Research is the foundation of academic excellence, policy formulation, and business innovation. In today's data-driven world, mastering statistical method is not just an advantage,
but a necessity for producing high-quality, evidence-based research. This workshop is designed to equip you with practical statistical tools, analytical techniques, and modern research methodologies that will enhance the depth, accuracy, and credibility of your academic and professional work. We are privileged to have experienced facilitators and experts in the field who will be guiding us through statistical data analysis technique and real-world applications. This is an opportunity to learn, engage, and collaborate with fellow academics and professionals who share a commitment to advancing knowledge and research excellence. I encourage you all to make the most of this training by actively asking questions and networking with colleagues. The insight gained here will not only strengthen your research capabilities, but also contribute significantly to the academic reputation of Federal University of Technology, Owerri. On behalf of CIBE and White Knight Consulting, I extend my profound gratitude to the university management for their support and to all participants for taking time to be part of this important initiative. Let us embrace this learning experience with enthusiasm and the spirit of inquiry. Once again, welcome, and I wish you a productive and rewarding workshop. Thank you very much, ladies and gentlemen. To confirm if you can hear us. Hello, Prof, sir.
Very well, very well. Loud and clear.
Distinguished participants, ladies and gentlemen, I would like to bring Professor Adebayo on board. But before that, let's quickly take a view of his profile. Professor Paul Adejola Adebayo was born in Gusau, Zamfara State in Nigeria. He is a distinguished academic and professional with interdisciplinary expertise spanning accounting, business, finance, forensics, and information technology. He holds a visiting professor at both Annan University, Kwab, and Nasarawa State University, Kefi, here in Nigeria. He has been pivotal in shaping the academic and professional landscape in this field through his extensive research, teaching, and consultancy work. In terms of professional qualifications and fellowship, Professor Adebayo Paul Adejola is a highly regarded fellow of several esteemed professional bodies, including Association of National Accountants of Nigeria, ANA, Institute of Chartered Accountants of Nigeria, ICAN, Chartered Institute of Taxation of Nigeria, CITN, Institute of Chartered Economics of Nigeria, Association of Chartered Certified System Accountants, SCCA Global, USA, Certified Institute of Business Entrepreneur, CIBE, USA, that is the body organizing this in conjunction with the center, Association of Forensic and Investigative Auditors, Canada. Additionally, he is an active member of the American Accounting Association. Academic achievement and publication of Professor Paul Adebayo. Professor Adebayo holds 3 PhDs from Nigeria, the United Kingdom, and Turks and Cyprus Island in business administration, finance and accounting, and forensic accounting and audit, respectively. He also earned a professional doctorate degree in economics, a prolific author, He has published over 30 books and more than 75 articles in peer-reviewed local and international journals. His contribution to knowledge extends to developing over 102 training packages designed to empower both accountants and non-accountants across Asia, Africa, the United States of America, and Europe. Professor Adejola also supervised the dissertation of over 70 postgraduate students, both within Nigeria and internationally, underscoring his commitment to academic mentorship and development. In terms of professional competence and skills, Professor Adebayo is renowned for his ability to formulate and implement strategic initiatives effectively. His strong quantitative, analytical, and problem-solving skill, coupled with his high energy and hands-on approach, make him a valuable asset in any team setting. He is recognized for his strong organizational and planning capabilities, which complement his role as a competent team player. Professor Adebayo also has received several awards and recognition throughout his career. He has received numerous awards recognizing his academic excellence and contribution to professional practice, including ICANN Prize for Best All-Round Graduating Student in Accounting, Corpus and Lebros Prize for Best Graduating Student in Auditing and Investigation, Bank of the North Limited Prize for Top Graduates, and Olu B. Obande and Joe Prize for Best Graduating Student in Taxation. He has also been honored as Honorary Mayor President of Baton Rouge, Louisiana, in the United States, and is listed in the prestigious Who is Who in America, as well as among the top educators in the United States for 2023-2024. In terms of professional experience and competency, Professor Adebayo has held several key academic and administrative roles, including former head of Department of Accounting, Nassau State University, KP, Director of Governmental and Financial Accounting Research Center at Nassau State University, KP, former head of Department of Accounting at Bingham University, Kawo, in Nigeria, accountant, Nigerian Law School, Owerri, Abuja, here in Nigeria, and head Internal Audit Unit, United Bank of Africa, PLC. His consultancy and collaboration span several institutions and government bodies, such as Southern University in Louisiana, USA, Visa Solution, United Kingdom, Nigerian National Petroleum Corporation, NNPC Limited, Kaduna State Government, and Nigeria, the Nigerian Army, and the Certified Institute of Business Entrepreneur, USA. In terms of leadership roles and global impact, currently Professor Adebayo chairs the Education, Training, and ICT Skills Committee of ANAM, and is actively involved in initiatives like the registration of ANAM branches in the United States of America and Canada. He also serves as the training director for CID in the United States and is the managing consultant at White Knight Consulting in Nigeria. A sought-after speaker and resource person. Professor Adejola regularly presents at international conferences worldwide. This is the certificate that was given to him in the United States. The Who is Who in the United States, presenting his contribution to academics, top professional educators, ladies and gentlemen, distinguished participants. I present to you Professor Paul Adebayo Adejola, who is a speaker for the fourth paper.
Thank you, Dr. Moa. Actually, I think in the academia, until you are a full professor, that's associate professor. He's an associate professor, actually. We return all the glory to God. I keep saying this each time citation or any accolade is given unto me. There is no any accolade. It is the backing of the extraordinary God that make an ordinary man appear extraordinary. I will return all the glory to God. Here in the US, I think I've been in the office like 1 a.m. because of timing difference. Because a man, I keep saying, no food for a lazy man. One have to work. I love what the last speaker said when that Professor Gloria, I can't fathom again, when she said, as academia, as professors, as PhDs, when we master these statistical tools, the sky is not even the limit, the starting point. I will start by saying that. But I will give honor to whom honor is due. The Vice Chancellor, Federal University of Technology, Owerri, Nigeria, the center leader, Professor Gloria, the directors, and our own member, that's Madam, what's her name again now? The accountant of the center, that's the accountant of the center. Distinguished professors, ladies and gentlemen, good morning. I will hit the ground running. Mine is to take the overview for today, and after taking this overview, that's Mrs. Ebere. I remember now, she's a member of the ACCSA Global. Mrs. Ebere, thank you for all your effort and for representing us perfectly there in FUTO. Now, I will take 2-in-1, what I've classified 2-in-1. We all know that theory is the basis for practice and practical. We just said and try to remind us of what we know already. But then, if there is anything in life that is permanent, they say it is change. And that's why we advise ourselves in the academia, in professional practice, that we should change as time changes and adapt ourselves to the environment, especially in this era that has been tagged era of digital revolution. Some other call it era of digital Darwinism. The knowledge we feel we have yesterday may not be adequate to face the challenges of today. No wonder somebody put it this way, say the illiterate of the 21st century is not someone who can not read or write, but someone who cannot learn, unlearn, and relearn. In workshop of this nature, what I will expect all of us to do, including we, the privileged facilitator, is to first forget about whatever we feel we know in the past, so that we will prepare our mind, we'll empty our mind, and learn new things. By the grace of God, I keep saying it's not just theory we teach. We are going to see even from the program of event and manual given to us, we have a lot of case studies. We are going to look into them, and that has been our own goal in CIBE as well as ACCSA Global, hands-on, because the world we are today is not a world of theory. When we talk of wisdom, wisdom is not in words, but in works. Correct application of knowledge. We have several case studies. Even as last night, I was still working on those case studies so that we have a maximum impact from this training workshop. The first paper we'll be looking at together, Statistical Methods for Research. I remember saying it's not theory we do. And I'm still repeating, going back to what the last speaker that say you are the one that will even beg the university to release you to go. As a matter of fact, you can see from my profile that I'm a visitor after working for like 21 years in Nasarawa State University. I had to request for a leave of absence in year 2020 for 1 year. And that 2020, why I requested for that leave of absence, I said, let me even see if I can survive without salaries. We are going to see more or hear more about this life after retirement or streams of income on Friday when I take that last paper. So I requested for 1 year leave of absence. I enjoyed it. I realized that I'm making minimum 5 times my salary. So when it was time for me to resume back to the university, I asked for an extension of additional year, 2 years leave of absence. After that 2 years, I said, can I resign? They said, no, I have to put him back the 2 years I've been away, or I pay them the salaries. And exactly 2 years after, that should be 2023, I've tendered my resignation doing what I am currently doing in the United States. And by privilege, I've handled research work in collaboration with our resource person there for Americans here, both students and even some lecturers doing their PhDs. And I will tell you, minimum I charge when I take up a research, that's just to help them analyze data and interpret, is $2,000. Minimum is $2,000. Time will not permit me to say a lot of things. I said, there, it must not be white for it to be right. So when we begin to change our mentality, that because some of us will feel if it's not Oyibo man, it's not correct. No. Here in the US, one of the university I'm consulting, they have a lab, accounting lab. They have the systems there, but they don't have accounting software there because the crop of professors or lecturers they have there don't have the skills on how to use the software. And it is a gap we are really bridging to bridge the digital divide in the teaching and practice of accounting and related discipline. Now, go straight to, let's see the screen, statistical methods for research. I'll be as fast as possible because as I'm doing this, our facilitators there on ground will be dropping the software on our desktop. Then after my presentation, we'll take the brainstorming session. Then we'll come and do installation. We have 3 software to be installed on our system. So I need to be fast with my presentation. So we'll have time for that. Opening verses. Ladies and gentlemen, I will not use ladies and gentlemen again. Professors and PhDs. In God we trust. All others must bring data. We trust in God because God will not fail. God is invisible, but he has proofs of visibility more tangible than what we accountants call tangible asset. But any other person before you trust, the meaning of all others must bring data, others must bring evidence. That's by Edward Deming. Another powerful and related quote: without data, you are just another person with an opinion, especially when it comes to research, when it comes to making impact, and when it comes to writing winning proposal for you to get grants. You have to back it up with data. And another last quote there: statistics is the grammar of science. Just like we in accounting, we say accounting is the language of business. So the only grammar that they speak in statistics is, the only grammar of science is statistics. Statistics is science of collecting, analyzing, interpreting, and presenting data. Provide structured methods to summarize and visualize data. That's why we're going to see some of this software we are going to use. You doubt what you hear, but people really doubt what they see. After putting the theory, we have some of these statistical software that will give you in picture form, pictorial representation of what is being written or the data collected. We are going to see. So it helps in identifying patterns, trends, and relationships in data. When we come later, maybe tomorrow, and we begin to look at AI, artificial intelligence application in data collection and analysis, that's where you'll be seeing descriptive analytics, predictive analytics, diagnostic analytics, and the rest. And all these things work with pattern when we go to AI and machine learning. Then forms the foundation of empirical research by enabling data-driven conclusions. That is statistics. Now, why is statistics important? Provide a systematic approach to analyzing large and complex data sets. We have what is popularly called big data analytics. When you are talking of big data analytics, we are talking of data that is large, that is voluminous. We talk of varieties and we talk of velocity. You have all this data in billions, some in gigabyte, terabyte, zettabyte, just name it. And yet you want to draw relevant one from this volume of voluminous data to make precise decision. We need it. Then enables hypothesis testing to validate or reject research assumptions. Again, I'm still referring to what our last speaker said about professors, highly respected professors. We are very excellent in our field, but I have to even share this experience. During my own defense, PhD defense, standard defense, honestly, I'm not trying to undermine or underrate any professor, but the external examiner who came to take that final examination when it was time for my own final external defense, I was the one that was explaining to him some of this interpretation. He never had idea about it. So it's not out of place that we are looking at this all together. So it facilitates comparison of variables and identification of significant differences. I say I will be fast as possible because we're going to make this slide available. Let's go to types of statistics. The very first one is the descriptive statistics. And I've said earlier that when we come to even data analytics, we have what's called descriptive analytics. So in descriptive statistics, you describe the situation, you summarize and present the data. You summarize, then you organize and simplify data for easy interpretation. For example, say a professor at Federal University of Technology, Owerri, is analyzing student test scores from a statistics course. The data set includes 100 student final exam scores. Descriptive statistics will help summarize the overall performance. We have some people at the top there, by virtue of their too much commitment, I won't say position now, they don't have time to read all the details. In descriptive statistics, just tabulate or you put it in a graph, they will see the flow, the pattern. Measures of central tendency, that's one of the area when we talk of descriptive statistics. We have the mean, that's average. You total divide by the number, depending. Example, the mean exam score is 65%, meaning most students scored around this value. Then we have the median, the middle value. If the mean score is 70%, half of the students scored above 70% and half below. That's just the interpretation. When you are aligning scores 10%, 20%, and you now say the mid value or median 70%, see the interpretation. Half of the students scored above 70% and half below. Mode, most frequent value. If the mode is 75%, it means most students scored 75. This is what the measures of central tendency. Then under the descriptive statistics, we have the measures of dispersion showing variability in scores. For example, when we say standard deviation, how spread out scores are. Example, if the standard deviation is 10, scores are moderately dispersed around the mean. Then we have variance. Variance measures how far each student's score deviates from the mean. If you say mean is 50%, and we are now saying that the difference, that's we are saying variance now, and we are now saying the difference is 20, and we have 50 as the mean. Difference of 50, difference between 50 and 30 is 20. That's the variance. Range, if the lowest score is 35% and the highest is 95%, the range is 60. Then we have the histogram to represent the descriptive statistics. We are saying that's the pictorial representation now. We have the bar chart and we have the scatter plot. Types of statistics, number 2, inferential statistics. Inferential in inferential statistics, we are talking of making predictions and drawing conclusions. Now, in descriptive statistics, we have collected the data. And based on the data collected, you make inference, you make prediction. Earlier on, I mentioned in data analytics, we have what is called descriptive analytics. We have what is called predictive analytics. Then we have what is called prescriptive analytics. You describe the situation. When you describe the situation by the data you have gathered, we have what is called diagnostic analytics. In diagnostic analytics, you want to diagnose why are we getting this result we are getting. Then in predictive analytics, that's inferential now. We want to based on the data we have gathered, this is what is likely to happen. Then we have the last one, prescriptive. You will now prescribe, just like someone who have gone to see a medical doctor. You describe your situation, they carry out the diagnostic analysis, then they tell you if you refuse to take this medication, this is what will happen. Then we have the final prescriptive analytics. Example scenario, a research team at FUTO wants to determine whether students who attend tutorials perform significantly better than those who do not. Instead of testing all students, they collect a sample of 200 students and apply inferential statistics. You see how inferential statistics is coming in now. Then the hypothesis testing, which is part of the inferential statistics, confirming or rejecting assumption. We have the null hypothesis, we have the alternative hypothesis. Example test. A t-test compares the mean scores of students who attended tutorials versus those who didn't. Interpretation of this. All these tests, we have listed them in our manual, and we are going to apply those software that will be installed on our system to carry out these tests one after the other. I'll say if the p-value is less than 0.05, the result is statistically significant, meaning tutorial attendance improves performance. Professors and PhDs, professional colleagues. Yet again, let me share another experience. In my university, I have a colleague who have been in the university for years together. Now he's a professor also. And when he completed his own PhD work, of course, when he got to the point of data collection and analysis, he gave it out. Someone to help him do. That's an aspect many of us in the university are really avoiding that. Okay, it's difficult. Thank God for AI. We are going to see the application of AI tomorrow and next. Tomorrow and Friday. Now, I advise him, see, even if you don't know how to run this test yourself, try and master the interpretation. And as if I knew what was coming. On the day of his final defense, the external examiner asked him to interpret one of the results there. And in fact, he even asked him what was the test used to get a particular result. He couldn't, but they had mercy on him. It's no major correction. He still passed. We can save ourselves some of this embarrassment by trying to get the right knowledge and apply it. So we say if the p-value is less than 0.05, the result is statistically significant, meaning tutorial attendance improves performance. I'll be very fast to conclude this. I have another second paper. Confidence intervals. Still, we're talking of inferential statistics, estimating population trends. Example, a professor wants to estimate the average GPA of FUTO students. Instead of collecting GPAs from all students, a sample is taken. If the confidence interval is 3.1, 3.5 at 95% confidence interval, see the interpretation here. It means we are 95% confident that the true average GPA of all students is between 3.1 and 3.5. That is the interpretation. So we've been hearing confidence interval, And once you set that, maybe 95% or some other percent, that's the key interpretation. Then see inferential statistics, we have regression analysis, predicting outcomes and understanding relationship. Example, a study explores the relationship between hours of study and final exam scores. A linear regression model is used to predict. So it's used for prediction. For every additional hour of study, a student's score increases by 5%. That is the prediction if you use linear regression. Or you take another question, effect of training cost. I'm not saying training, of course, training is not free, it's cost. Effect of training on performance. Here is regression. You want to see the effect of the money you have invested in training, in workshop, and similar things on performance. And here maybe performance is measured in terms of course, productivity, or we in accounting will say in terms of profit. You can use regression to do that. Types of regression, we have simple regression. This one predicts exam score based on study hours. Then we have multiple regression, predicts performance based on study hours, attendance, and prior GPA. Okay, I'm talking to learner colleagues now. No need to explain this. There's a difference between linear and multiple. Like the example I gave, effect of training or effect of investment in training on performance. If your yardstick to measure performance is only profitability, that means you can use linear regression. But if you have other parameters to measure performance, other than just the profit you are making, you also have revenue, you also have return on investment, and so on, then it is multiple regression. Steps in statistical research. Steps, we have defined the research problem. I'm not going to waste time in this because I remember before leaving Nigeria, we have a research book, a guideline that we give to our postgraduate students. We have that of undergraduate. All these steps are listed there. Define the research problem. Number 2, collect data, like surveys, experiments, or secondary data, as the case may be. Step 3 is to organize and clean data. So in data analytics, we have what is called data cleaning. Some people call it data cleansing. And some other will use data manipulation. You are not manipulating to falsify record. All we are saying is that when you collect all forms of data, it is not all this data that will be germane to the decision you want to make. So you have to do the data cleaning to remove the one that will distort the inference or the conclusion you are going to make from the data. So that's what we do in data cleaning. And here we say, check for missing values, inconsistencies, and errors in data set. Apply data cleaning techniques such as standardization and coding. Ensure uniform formatting and categorization of variables. Then we say, remove duplicate or irrelevant data to maintain accuracy. That's what we do here in data cleaning. Then we have the next step, step 4, apply statistical methods, either descriptive or inferential, or both. Use descriptive statistics to summarize and visualize the data. Then apply inferential statistics to test hypotheses and draw conclusions. Then select the appropriate statistical technique based on data type and research objective. And the good thing about this training is that the statistical tools we have lined up for this training cut across various disciplines, whether it's social science, whether it's arts, or whether it's science, as the case may be. Then the last stage is interpret and present findings. And here we are saying compare results with research hypotheses to draw conclusions. Use tables, graphs, and statistical summaries for clear presentation. Report findings in structured and comprehensive manner. Provide actionable insight based on statistical evidence. Descriptive statistics. central tendency measures. You say mean, I mentioned this earlier, so I'll just skim and skip through all this. Median, then mode. Descriptive statistics continue. Variability measures, we have the range, we have the variance. For example, we say the range, the difference between the highest and lowest values, gives a quick measure of data spread, but does not account for distribution. Then we say variance, measure how far data points are spread from the mean. The larger the variance, the more dispersed the data. Maybe the lowest person score 20 and the highest 100. See the difference now, 80, that's the gap. Standard deviation, square root of variance, providing a more interpretable measure of spread. Higher standard deviation indicate greater variability in the data. Then the visualization tools, that's the pictorial representation of data now. We have tables, we have bar charts. You can see all the pictorial representation by the right-hand side. Histograms, pie charts. Then inferential statistics. We say concerning inferential statistics, it is used in drawing conclusion from sample data. See, the first one, your hypothesis testing, determines if a result is statistically significant. Used to test assumptions about a population based on sample, involve defining a null hypothesis and alternative hypothesis. Results are interpreted using p-values to determine statistical significance. Helps in decision making by confirming or rejecting claims based on data analysis. Then confidence interval, we have seen this. Regression analysis, I'm just giving us in details those I highlighted earlier. Now see a very good example here, how income level affects spending behavior. A study investigates whether higher income level lead to increased spending. Regression analysis is used to determine the strength of this relationship, the strength. Correlation will determine the relationship, regression will determine the strength. If a positive correlation exists, an increase in income predicts an increase in spending. That would be our interpretation. Findings help businesses and policymakers make informed economic decisions. In hypothesis testing, still part of inferential statistics, we say making data-driven decision. Whose hypothesis is testing is a statistical method used to determine whether there is enough evidence in a sample to infer a conclusion about a population. That's why we say reject the null hypothesis, then accept the alternative hypothesis. We have the null hypothesis, no effect or difference. Then we have the alternate hypothesis, say there is an effect or difference. Steps, we have steps in hypothesis testing. Step 1 is to define the null, that HO, the null hypothesis, and the alternate hypothesis. Then choose significance level. I would say the most common significance level is 5%, meaning there is a 5% chance of rejecting the HO when it is actually true. Step 3 says select statistical test. What is the test relevant for the case you are handling? Is it t-test? The t-test compares means between two groups, e.g. male versus female student scores. ANOVA, that's analysis of variance, compares means across multiple groups, e.g. performance across 3 different classes. They will have the chi-square test, determines relationship between categorical variables, e.g. exam pass-fail rates by gender. We are going to see all these things practically apply when we come to the practical sessions. And the next step is calculate test statistics. That is, compute the test statistics, e.g. t-value, f-value, chi-square based on the data sample. Then the last step is compare with critical values and see the interpretation here. These are areas we really need. If the p-value is less than 0.05, reject HO. There is a statistically significant difference. If the p-value is greater than or equal to 5%, fail to reject HO, no significant difference detected. Examples. Compare exam scores. That is the example we want to see here. A researcher wants to determine if students who attend tutorials perform better than those who don't. See the null hypothesis here. There is no difference in exam scores between tutorial and non-tutorial students. There is no. Then the alternative hypothesis says students who attend tutorials perform significantly better. And the relevant test for this example we are sharing, a t-test, is conducted to compare the mean scores of the two groups. That is, you look at those students who attend tutorial, look at the mean score of those who do not attend tutorials. We are not talking of, I know sometimes, but in reality, in real life, there are some people that are really gifted. They don't need tutorial. They are really gifted. They do some other things. Let's leave down. But here we are talking of data. We are talking of research. So you collect the mean exam score. There's this exam score of those who attend and those who do not. Then you carry out the test. Now see how you come up with your conclusion. If the p-value is less than 0.05, we reject the null hypothesis. And rejecting the null hypothesis means we are coming back to this now. We now say if you reject HO, you are taking this. Students who attend tutorials perform significantly better. Common statistical tests. I'm going to see the detail. We have the t-test. The t-test compare means between two groups. We have the ANOVA compares means across multiple groups. Chi-square test examines relationship between categorical variables. Correlation analysis measures the strength of a relationship between two variables. Regression analysis explains relationships and make what? Predictions. Make predictions. And here we have the test, we have the use case, then the example. Let's skip this. Data collection method, basically we know in research, we have the primary data collected directly from original sources. And methods of collecting primary data include but not limited to what we have here on the screen. We have the surveys and questionnaires, we have the experiments, we have observations, and of course, the advantages of this include tailored to specific research need, provides up-to-date and first-hand insight. Disadvantages, time-consuming and costly, requires careful planning and to avoid biases. Then we have the secondary data, and the common sources for the secondary data include existing reports and databases. We have government publications, academic research and journals. It has its own advantages, which include readily available, time-saving and cost-effective, useful for large-scale studies and historical analysis. Disadvantages, data may be outdated or not fit the specific research objective. Now, if I just pause a while, let us see reaction and contribution. We want this workshop to really be interactive because there are a lot, nobody has the monopoly of knowledge. There are a lot of things some of you are exposed to there, even in our country, Nigeria, that myself now, who has, do I say I've not jackpot, I've not migrated, I still come to Nigeria as the need arises. But to the glory of God, I have my permanent residency here in Nigeria, here in the US. Now we pause here and say, this what we have discussed now on secondary sources of data collection. And we are talking about data analytics for research. We have to also collect existing data, sometimes from our Bureau of Statistics, that's in our nation. The question is, how reliable are those secondary data? How reliable? Can we rely on those? Because one thing about data, once they publish this data about Nigeria, I've seen conflicting data. If World Bank is going to carry out maybe a study on the nation Nigeria, focusing on a specific sector, you will see them give their own side of according to what their findings. But the same data they use will not be the same with the one with relevant authority as published concerning our Nigeria. What is our opinion on this anomaly? Any contribution? Put in another way, how reliable is our data? How reliable are they?
The Prof has just
Alright.
asked a question. If there is anybody that wants to contribute that how reliable is our data?
Especially secondary data. When I think recently, if we follow news, I read news about our nation, they arrested some staff from that Bureau of what do they call that? Bureau of Statistics. Those responsible for releasing data about Nigeria. I think they gave some unfavorable information about our economy and they were arrested. So the question we are asking, because garbage in, garbage out, the kind of data you collect, of course, will affect whatever decision and inference you are making. So how reliable? And we say how reliable is our data as a nation and what can we do about this data we collect for purpose of research?
Yes, Prof, somebody that wants to respond to your question.
Please go ahead, sir. Oma.
Yeah. Thank you, the guest speaker. My name is Professor Ben Usrumba, a member of the Nigerian Economic Society. Your question is very, very important. One thing is this, depending the purpose. Bureau of Statistics is a government agency, and it has to, like you talked about, data cleaning. Before it releases any data, it has to get clearance from the master. It has happened before with the issue of inflation. We'll be having hyperinflation, galloping inflation, and are trying to cook doctor, massage, so that they will not displease the paymaster. And so that's why, thank God you have other independent data originators. And so those of us that are involved in economic research, you may fall back to either World Bank data. For Nigeria, you begin to wonder, and sometimes you have a poster of data that there are certain aspects that has to do with even human development, human capital development data, and you still find it difficult to get it, from the government agencies, and that is a major challenge to researchers. This issue of relying on data from your own economy, and so that's why some people believe that primary data is more acceptable and more, and that's why some researchers they prefer you carry out a survey, just like the one we are doing with World Bank, because you meet the real person. The issue of poverty, you can't get poverty in Abuja. is when you get to the hinterlands. If you come to my village, you see the poor of the definition of poverty. The definition of poverty. If you come to my village, so you see the definition of poverty outside the theoretical definition. Because somebody in Abuja may not know the definition of poverty. And so that's why I agree with you and I support what you said. Thank God we have independent researchers who now generate reliable data you can even rely more than the government agencies. It's just like the issue of propaganda, US using CNN, and then the Nigerian government using NTA. The emergence of liberalization in communication that you can now have independent media that you can rely and get better information. Thank you. That's my contribution.
Thank you, sir. Thank you, Prof, for that contribution. Any other question?
Yes, talking about the reliability of data coming from Nigeria, I think another problem to what Prof said is because of weak institutions. Because Nigeria, we have weak institutions. The Bureau for Statistics, if we strengthen our institutions, that bureau is supposed to be independent, supposed to be well funded. And if they are not independent, if government determine their funding, it means that government will still determine the kind of data they dish out. Again, talking about independent researchers, relying on independent researchers, the data they how many independent researchers do we have here? And what is the volume of data independent researchers without funding can dish out? You find that also there's a problematic in that area.
Yeah, correct.
So ethnicity and primordial influences. When you talk about like census report, you still feel that there is still the polity of Nigeria going on with some of these figures. Since these figures are tied to allocation and distribution of resources, you still see that there are people that have to underhand businesses in order to doctor the data to favor their region. As long as we are still battling with some of these primordial things and we have not grown beyond that and start to be nationalistic in the things that we do, we'll still be bedeviled with this problem concerning data. Thank you.
Thank you, Prof, for that contribution. So we can now draw conclusion because there is a problem. The essence of identifying this problem or any challenge is to find a way out. So will it suffice now to conclude that when we talk of the reliable data, let me put that language now, data that is reliable for purpose of forming an opinion, the primary data is better, preferable than the secondary one. Is that what we are saying now from our reactions to the question? That is the primary source of data collection or primary data is better than the secondary. Is that the position? Because we in accounting, there's what we call window dressing. The first professor who reacted to that question talked about manipulation. Government is the one who pay these people, so they want to doctor the data. In account, we call it window dressing. That's what we call cosmetic accounting. That's what we call makeup accounting. That even our financial report are not reliable. There are a lot of problems. So, but let's leave the problem. We will not be talking of the problem. We want to see the solution, the way out. Do you imagine an external auditor giving us stakeholders assurance in that auditor's report that in our opinion, the financial statement represents a true and fair view? yet there are problems there. They have window dress. They have performed makeup. They call it makeup accounting, cosmetic accounting, income smoothing, earning smoothing. When it is time to attract people to come and invest in the company, there is a way they will fine-tune the financial statement, manipulate data to make it look attractive. That's why it's good for us to also do our own personal analysis when it comes to decision making. Let's take the next slide. Sampling techniques. We have a process of selecting a subset of individuals from a larger population for study. One thing about sampling, as we are going to see later, though it's allowed in research, well allowed. But with the statistical tools we even have now, especially the application of artificial intelligence and machine learning, that will even allow us to take the whole population as long as you have the data. You can take the whole population. And this thing, within minutes, you'll be able to do the analysis. It's not human being now that you are the one doing it. Artificial intelligence. Types of sampling techniques, we have the random sampling, stratified sampling, systematic sampling. And the random sampling, we say every individual in the population has an equal chance of selection. Then when we talk of the stratified sampling, population divided into subgroups called strata before sampling. Then systematic sampling, we are saying selection of every individual from a list in a systematic way that will make it possible to have a representation of all the population of all the class, all the group. Importance of sampling ensures the sample represents the population accurately. And that is another area we have challenge, even when we come to this misleading financial report. Auditors will tell you that in carrying out their report, because they've challenged them before, why have you given an unqualified audit report telling the whole world that everything is well? And at the end of the day, some things are not well. The guy will give an excuse. They will tell us that in auditing, sampling is allowed. And it's possible that the areas they did not sample has been the reason for the problem, why the company fold up or the company had to be liquidated. Data collection method. We say data quality consideration in data collection, ensuring reliable and meaningful data. That is, in data collection method, what should be our focus? One, accuracy. Data must correctly represent the real-world values or responses. Reliability. Results should be consistent when measured multiple times. Validity. The data should measure what it intends to measure. Consistency. Uniform data collection and processing methods must be followed. Then the question we ask again here, how to improve data quality, which we still go back to part of the contribution from the last two speakers. So use standardized data collection tools, e.g. structured surveys. And if you marry this, just link this with what we have discussed earlier, that we are saying we have secondary data, we have primary data collection. This one is a structured surveys. That means this is primary. Then conduct pilot testing before full-scale data collection. Pilot testing before full-scale data collection. And I would recommend here also part of what our Prof said earlier, the first person who contributed, that we should consider alternative source of collecting this data. Instead of relying on the one from our Bureau of Statistics, we can rely on data from World Bank. And especially some of us who, after this training, you are looking for opportunity for grants, award-winning grants. Maybe we'll talk to our center leader. If we can, in future, we look at another training. That one may be for 2 days or 3 days. Number one, in that training, we focus on organizations we have here in US who give grants to researchers, because my green card was approved in less than 1 year based on the fact that I am into research. They collected, of course, they call that one EB1. They look at all my publications, a lot of things. Don't let me digress now. So if we can come up with another training in that area, how to write a winning proposal. Maybe you have a project you have identified. How do I write a proposal to get grants? Because I interact with these people who write proposal for people, and one of them not only write, people who even access all submission. And one of them, when we were talking, told me, you know what they do? That when they receive proposal from different sources, I hope this one is not digress, but we need it. The essence of a meeting like this is for us to be able to gain and add value to ourselves, not just research, something that will add value. Now, the guy told me that what they do when they collect all these applications, people have submitted proposal for grants. All they do first, in order to reduce the number to the barest minimum, they start looking for errors. So once they pick this one and they just identify errors, they put it aside. That's how they solve until they narrow it down to the ones that are without error, faultless, and meet the requirement. You can come up with things, organizations, that's opportunities for grants, then how to write a winning proposal for purpose of grant. Now, how to improve data quality? The third one, we say ensure data verification and validation before analysis. Hope you can still see my screen. Sorry, I have to slideshow. All right. Challenges in statistical analysis. Poor data quality, incorrect text selection, misinterpreting results, bias in sampling. And if you look at this, it's still part of what we have discussed, including the two contributions, poor data quality. That's what we have been talking about. Because if we say the current slang or the popular slang, garbage in, garbage out, if the data that will form the basis of decision making is faulty, how faulty will be the decision? That's what we are saying here. Incorrect test selection, maybe we have not chosen the right one. Then misinterpreting results, bias in sampling. That if the sample we have used that serve as the basis for our test and conclusion are not representing the entire population enough, that means there's problem. Case study, as I conclude this session, real-world statistical application. That's what we see in this case study. Scenario, analyzing the impact of training programs on employee productivity. I've been saying that if we spend millions to go and attend training, whether within or outside the country, what is the impact of this investment? Because I tell people, any amount of money you invest in adding value to yourself should not be treated as expenses that will debit to profit and loss account. It should be capitalized as an investment. And for every good investment, there is expected to be a good return. So we want to see the impact of training programs on employee. Objective, you can set this objective. A researcher aims to determine whether a training program significantly improves employee productivity. The study now. See the question. Does the training program lead to a measurable improvement in employee performance? And it still boils down to what I've said earlier, that how do you measure employees' performance or the productivity? Is it in terms of output now, or in terms of profit, or in terms of revenue? Maybe FUTO want to increase the streams of income, multiple streams of income. and they say, okay, go for a training on how we can enlarge the revenue coming to FUTO. And after this training, you have recommended these are the ideas we should do. So that one is measurable. Let's see. Step 1, this case study, collect pre-training and post-training scores. Data collection method is a measure employee performance before training, baseline score. Conduct training and allow employees to apply new skills. Then measure employee performance after training, that's post-training score. Then the performance metrics that you can use for this particular case study in task completion time. Can you see now? How do you measure performance? Quality of work, error rate, customer feedback, productivity levels, output per hour, efficiency rate. So these are yardstick now to measure the performance or productivity of the employee. Step 2, apply a peer test to check improvement. And the question is asked here, why use a peer test? Compares two related data sets before and after training from the same group, helps determine whether observed changes in performance are statistically significant. And see the statistical hypothesis here, the null hypothesis. Says training has no significant effect on productivity. Of course, the alternative hypothesis saying training significantly improves productivity. Then you perform your test. Once you have the hypothesis, see the test now, calculate the mean difference between pre-training and post-training scores. Perform a peer test to check if the difference is statistically significant. Then say compute the p-value to assess the strength of evidence against the null hypothesis. Step 3, interpret the result and make recommendations. Result interpretation criteria. If p-value is less than 5%, training had a significant positive effect on employee productivity. And p-value is greater than or equal to 5%, no significant improvement detected. Other factors may be influencing results. All this, we are laying foundation. By the time we have the statistical software installed, we will practically look at all this. And finally, software for statistical analysis. What are there? A lot of software. We have the first one here, SPSS, easy for social sciences and research. STATA, econometrics and panel data analysis. EViews, econometrics and time series. R and Python, advanced statistical computing, then Excel. Of course, we also have the AI. But for purpose of this training workshop, we have chosen just 3. We'll look at SPSS, we'll look at STATA. That's the first 3 now. We'll look at EViews. Then we'll now look at artificial intelligence and machine learning application in data analysis. Key takeaways as I conclude: statistics is essential for research and decision making. They say descriptive statistics summarize data, while inferential statistics test hypotheses. Choosing the right statistical test is critical for accurate analysis. I will say data quality and correct interpretation are key to meaningful results. In our own country, let me share this with us. We should not give up as professors, as PhDs, but let me see, generally as supervisor. Somebody drew my attention one day in my university, say, sir, you see one of the reasons I've said we should not waste time delaying students from graduation in the name of this their thesis or dissertation. If this guy now showed me, see all the past project, these students have, what are we doing with it? Are we applying the findings from this project? And he showed to me under the staircase where they dump all these things. We should not be discouraged. That's why some developed countries, like here in the US, Southern University to be specific now, at least the few students have assisted during their PhD work. They will allow them to even do their presentation. Of course, they will submit soft copy. Then they will allow them to do PowerPoint. Come and present, use PowerPoint, where they have guidelines on the use of this PowerPoint so that students will not just be reading. They want to know that you know your work, you know what you have done, you know your study. So they don't waste time again asking all this, go and do hard copy, because it's really occupying spaces. I'm not saying we should do that in our university. Every university have their own policy. Then I say we should not be discouraged that if they don't use some of these findings from the projects or thesis or dissertation from our university, our own focus should be that as a researcher, as an academic, there are countries who give recognition to those who are doing their job with diligence and ingenuity. So the result or the reward is there. Closing verses. You can have data without information, but you cannot have information without data. Data is the plural of datum. Data is informational raw material. I'm just explaining this, what Daniel Case is saying. Data is the informational raw material that need to be collected, processed, and generally worked on to produce information. Then, a well-designed statistical analysis turns uncertainty into insight. Uncertainty. We live in a world now, people say, I don't like to peculiarize our problem in Nigeria. I keep saying it everywhere, every part of the world. They have problem. When we talk of galloping or global inflation, inflation is not peculiar only to our country, Nigeria. There's global inflation. There's inflation everywhere. Before now, a gallon of gas, that's petrol, fuel, we call it gas in the US, a gallon, which is 4 liters make a gallon. We buy it for $1.67 to a gallon, a gallon, 1 gallon. That's 4 liters. Whereas at today, even though we have price variation, you can see 3, 4 gas station close to themselves, everybody different prices, but there's no one that is less than maybe $2.97 per gallon. So it's everywhere. So we live in a world full of uncertainty. With the right data, that's what my very self is trying to say here. With the right data and the application of the right statistical tool and analysis, uncertainty will give way to insight on how to navigate through the uncertain world and be able to take a decision. I tell people, as academia, as individuals, as a leader, always try to take a decision. We should stop giving excuses. If I take this decision, we are in a country, things are uncertain. No, you will not give that as an excuse. You don't give excuses, so you will not be excused out. So always try to take a decision, because failure to take a decision will quickly brand you as unfit for a position of responsibility. Though not all our decisions are expected to be correct, but it is better for us to be 51% right at all times and get something done than to get nothing done merely because we are afraid to take decision. So we have to make decision. Out of obscurity, there will be limelight. Then the last one, garbage in, garbage out. I've said this earlier. Data quality determines the quality of conclusions. Discussion and questions, open discussion now. I will leave this for us later. And here are the questions for open discussion. What challenges have you faced when applying statistical methods? Number 2, how can statistics improve decision making in your field? And the third question, what statistical software do you use and why? Please, if we can screenshot this, we pencil it down. It will be a kind of feedback. We will need it. You can get the material shared for this training workshop. You can get a paper. If you can just help us pencil down. If we leave it to be open discussion, it may take our time. If you can help us pencil down something. What challenges have you faced when applying statistical method? How can statistics improve decision making in your field? What statistical software do you use and why? We want to get this very brief and help us hand over to our representative there. Is feedback we need to know future area we can delve into to improve what we do as well. And thank you for your attention. Thank you very much.
Hello, Prof.
Yes.
Please, you will still display the last slide so that we'll get those questions.
All right.
Thank you very much, Professor Paul.
Thank you, ma'am. For ma'am, ma'am.
Hold up, Prof.
Yes, I have another. You give me another 15 minutes. The paper is actually 2 in 1.
Oh, really? Okay, let's regain our breath in this one before.
All right, ma'am. All right.
For some of us, you touched the pain points. Text, t-test, chi-square, regression analysis. For some others, they are very comfortable with it. But what we want to take away from this workshop is for everybody to be comfortable with it. So that at the starting point, your student is bringing out that problem statement, you already can critique the research question. You already have ideas on what to look out for in those solving questions. Because if they get the questionnaire correct, you'll be able to analyze it and you'll be able to get the actual results. One of these guys in statistics have one question. Is it going to be a short one? He has 1 second, while others are regaining their breath, taking down this discussion. So come up here, you have 2 seconds only.
Thank you, ma'am, for that response. Comment.
Thank you. My name is Tikanako. So please, my question is, we believe so much in World Bank data, and this program is centered on World Bank. And after the program, they are going to publish the data for the period, and we all believe in that data. What we benefit is the funding, but the indigenous, the enumerators, the supervisors that collect this data are Nigerians. And that is why I will ask the question, why do we believe that World Bank data is more reliable than the National Bureau of Statistics?
Thank you. Please, that question, I want one of us there to, even yourself, you know the answer to that question, but then I want somebody among the attendees to respond to the question before I lend my voice.
Yeah, the truth is that ever since World Bank is conducting survey, they use enumerators like us, supervisors like us in the field to collect the data that they publish in their database. And when the secondary users uses that data, it starts perfect. Then the data that the MBS collects is that same method, and yet it's not reliable. Thank you, Prof.
Any reaction from the house?
Yes, sir, there is one.
One response on it.
I need to say that I'm not too comfortable at that. I understand your sentiments, but their sentiments, but I think the issue is clear. It's a matter of institutions, how strong our institutions are. And of course, institutions are weak. leaders are stronger, and then they have this right to influence and interfere with anything they want to interfere. Interference, governmental interference is what happens. In one bank, they have stronger institutions, monitoring and evaluation strategies that make sure they follow what they are doing to the letter.
Thank you.
In the other case, you can be stopped in the way and said, why are you doing that? Who told you to ask that question? You can get it from our government every time. We know our problem. The same intellectuals. Okay, let me answer the last speaker. What is it that when somebody schools here, makes you to he goes abroad and start making distinction? The thing is that the system is so choked up, so unorganized, and so streamlined to favor government. In fact, there's total government interference. Take away from that, it's still the same individual. So one bank to be far more perfect than the Bureau of Statistics because there's control.
Okay, thank you for your response in that. Another insight I want to give about World Bank data is that they use several sources and they compare. Mr. Chama for say here. You submit, for example, for this project, we send our results. They send another team to come and verify our results. There's another team that also calls me on the phone, calls Dr. Iwu on the phone to ask, this thing you submitted, are you sure it's correct? Can you vouch on it? So they use several sources to do several comparisons. I'm not sure that validation. So I'm not sure that the National Bureau of Statistics do go into detail in doing all this. But they may be doing it. But because we don't trust our system, we just see here and say, this is Nigeria, is not good. A lot of things are good. Several things are good. There are more good people in Nigeria than the bad ones. And I am optimistic that this country will get there one day.
Amen. Amen.
I believe in democracy. Do you want to stretch your legs for 2 minutes and use the toilet before Prof does another 15 minutes?
Yes, ma'am.
Then after that 15 minutes, we take a good photograph. Is that okay by you?
Perfect, ma'am. Perfect.
So they have 2 minutes. We have our spaces. If you want to use the toilet, you're free. We have at this end, we have at that end through the conference room. You can stretch your leg, you can make that important phone call. 2 minutes starts now. Thank you.
All right.
So they are also going to be dropping the software on your laptops for those of you who will become first.
Prof, sir.
Go ahead.
Yes, they just requested for 2 minutes to.
It's in order. It's in order. When they are set, you let me know.
All right.
Thank you.
To see you, Prof.
Well done, sir.
Yes, sir.
All right.
Okay. I will call you now.
Can you be put in a drive? We have good network. Network has not been since we started. Where are these IT people? It's better they put it in the drive. Give us a link to take it from there. Because Google will protect us.
Please, let's settle down in business once again. Let's come in, want to push on the next item on the agenda. Please, let's come in, let's settle down and continue. Want to once again hand over to Prof. Paul Adejola for the next session that we want for the next present. The reliable informed us will take just 15 minutes. That's before we go into the brainstorming session. Prof, sir, over to you.
Thank you, sir. In this second presentation, welcome back. In this second presentation, as fast as possible, we'll be looking at statistical software for research, a step-by-step guide. Earlier, I told us for the purpose of this training workshop, we'll be looking at just 3 of such software: SPSS, STATA, and EViews. So I'll just run through this. Now, by the time we have the software installed on our system, you also need this slide step by step. If you want to run a data or you want to run a test, you have the data you've collected. And I will be as fast as possible. Outline: statistical package for social sciences, STATA overview, then EViews. SPSS, a powerful statistical software widely used. This one is important so we know the tool that fits a particular data analysis. That's the essence of this next paper. Used for data analysis, hypothesis testing, and predictive modeling in fields such as social sciences, business, healthcare, and finance. Key features of SPSS: data management, because I want to spend exactly 15 minutes. I will not go into detailed explanation, but it's good. We just have a feel of it. Data management, time series analysis, data visualization, descriptive statistics, panel data analysis, machine learning and predictive analytics, regression analysis, hypothesis testing. The meaning is that SPSS will do all this minimum for us. So you see the one that is relevant. What do I want to do per time? You now look at the one that can handle it. Or the 3 can handle a lot of things, but you see the one that is more convenient and appropriate for the situation on ground. Next, practical steps in SPSS application. Step 1 is importing data You can see those steps, how to import data. Step 2 is data cleaning and management. You can see the relevant steps under step 2 because of our time. Then step 3 is descriptive statistics. That's the basic summary, cross tabulation, data visualization. And I have a screenshot of the SPSS software there. Practical steps in SPSS application. Step 4, say regression analysis. That is with SPSS. You can run the regression analysis. Under this, we have ordinary least squares, OLS regression. See, step by step, click, analyze. It's even telling you what and what to click on how to use this software. Then step 5 is hypothesis testing. And under this testing, we have the t-test, ANOVA, chi-square test with the step on how to use the software about to be installed on our systems. Then we have time series analysis, stationarity test, ARIMA model, seasonal decomposition. Then step 7, exporting results. This is where you export your final result and the interpretation. This, in brief, the AI application and data analysis. We are going to see that is we can use AI to help us analyze data in a similar fashion as we have SPSS we do for us. In conclusion, I say SPSS is ideal for what? Data cleaning and transformation, descriptive and inferential statistics, regression and econometric modeling, hypothesis testing, time series analysis, and data visualization. Then we'll go to the next one, STATA. STATA is another software to be installed on our systems and to be practically demonstrated using those case studies. We have more than up to 20, about 20 case studies. There are about 4, 5, 9, then plus about 20. We are going to see all this. That's 4 case study for EViews, 5 for STATA, then about 12 for SPSS. And all this within a twinkle of an eye. We'll see that as from tomorrow. STATA is a powerful statistical software package widely used for data analysis, econometrics, biostatistics, and social sciences research. It is known for its flexibility, ease of use, and powerful statistical modeling capabilities. Key features of STATA, we have the data management, that is, can import or export from Excel and every other source. Even from SPSS, you can import data if you are using STATA. Now we have descriptive statistics, key features now, regression analysis, time series analysis, panel data analysis, survivor analysis. That is the feature of STATA. Then key feature of STATA continue, hypothesis testing, graphics and visualization. Then we have the practical steps in STATA application. I've said earlier that I'm sharing this, we need it as a guide. That after the installation is done, there may not be time tomorrow and next for the person taking this session there to be showing us this is the first step. While we are doing it, of course, you follow the step, but we have it written and you have all this to follow. Maybe another time you want to try to use those software. Step in importing data, method 1, method 2, we'll see that. Then step 2, data management. We have step 3, descriptive analytics. Then step 4, regression analysis. Step 5, time series analysis. Step 6, hypothesis testing. Is very important. I emphasize here that it's not a must that you have to follow this step chronologically the way I've arranged them. It depends on what you actually want to do. It depends on the problem you want to solve per time. If, for example, I just want to run this time series analysis, you may not need We'll do some of the other ones. Just go straight. Then we have hypothesis testing, forecasting, exploring results. There are AI application in data analysis. We are going to see this when we come to artificial intelligence and machine learning. As a matter of fact, from our program of event, what I titled is cloud-based solutions in data analysis. So when we get there, we look at some of these tests. How do I run data? How do I analyze data? Rather, using artificial intelligence. And I've had Prof. Gloria Ma had a while ago. I'm not sure if she's the one who said that you have strong internet connection in that center. That's a good one, because we will need strong internet access when we come to the cloud-based solution to data analysis. Then in conclusion, we say data is a robust tool for data management, econometric modeling, time series analysis, panel data analysis, hypothesis testing, and data visualization. The last one is EViews, econometric views. EViews, a powerful statistical and econometric software primarily used for time series analysis, forecasting, and econometric modeling, widely used in economics, finance, social sciences, and business research. And see the key features. It can do all this for you. Time series analysis, econometric modeling, forecasting, panel data analysis, statistical and econometric tests, graphical and data management capabilities, Monte Carlo simulations, and bootstrapping. Who uses EViews? Economists and financial analysts, academic researchers, government agencies, central banks, business analysts. Various areas of applications of EView include, but not limited to, macroeconomic forecasting, inflation, GDP, exchange rate, financial market analysis, stock prices, interest rate, risk management. We have credit risk, financial modeling, then policy evaluation, effect of monetary and fiscal policies, business strategy, demand forecasting, pricing strategies. And of course, we all now have the steps, practical steps in the application of EViews for data analysis. Step 1, installing and launching EViews, importing data into EViews, exploratory data analysis, EDA, then time series analysis, regression analysis, then of course, AI application in data analysis with specific focus on EViews. That one is doable, and by God's grace, we are going to do a practical demonstration of this when the time comes as per our timetable. Conclusion: EView is a robust tool for econometric analysis. By following these steps, you can perform descriptive analysis, regression modeling, time series forecasting, then panel data analysis, panel data. To conclude this session, numbers may speak, but it is the researcher's responsibility to interpret them wisely. Statistics is not just about numbers. It is about making informed decisions based on empirical evidence. SPSS provides an intuitive way to analyze social sciences and business data with ease. STATA empowers researchers with advanced econometric and statistical modeling. EViews enables precise forecasting and time series analysis for predictive insight. And we say by leveraging these tools, we can transform raw data into meaningful insight for academic and professional research, make data-driven decisions that enhance credibility and accuracy in findings, embrace cloud-based and AI-powered analytics to stay ahead in the evolving research landscape. And we say next step. Your next steps: apply these statistical tools in your research and publications, explore advanced techniques like machine learning for predictive analytics, continue refining your skills statistics is an ever-evolving field. Final thoughts. Say the future belongs to those who can analyze data, extract meaning, and turn knowledge into action. Again, say thank you for your attention. And as we conclude this session, I will draw our attention quick to what we are to see in our case studies. And in that order, they have been arranged in the training manual, the manual given to us. There is a test that we are going to look at from tomorrow. I don't want us to miss out in those practical sessions. We'll see one sample mean test, t-test. The purpose of that is to compare the mean of a single sample to a known population mean to determine if there is a significant difference. And where is it relevant here? In assessing whether students' average test scores differ significantly from the national average. That is one area now of focus. That's the area of focus of that particular test. Then you can check from the manual we have. We also have case studies, which we're going to use SPSS to demonstrate tomorrow. Two sample t-tests, that's independent t-tests. The purpose of that is to compare the means of two independent groups to determine if there is a statistically significant difference. It's just like comparing male and female students' exam performance to see if gender influences scores. Then we have another case study we are going to see tomorrow, paired sample t-test. The purpose of this test is to compare two related samples before and after treatment to determine if a significant change occurred. For example, when you want to evaluate the effect of a training program on employee productivity by comparing scores before and after training. Then another test is the chi-square test. The purpose of this is to test for association between categorical variables in a contingency table. For example, in determining whether gender is related to students' choice of STEM versus non-STEM courses. We are going to see another case that's a test on one-way ANOVA. This one compares the means of three or more independent groups to determine if at least one differs significantly. For example, when you want to analyze whether student performance differs across multiple universities, ANOVA is the one relevant to do that. We have the two-way ANOVA. This examines the effect of two independent variables on a dependent variable, including interactions. For example, you want to investigate how teaching method and student gender influence academic performance. Then we see Pearson correlation. This measures the linear relationship between two continuous variables. And of course, when you calculate the correlation coefficient, it ranges from -1 to 0 to 1. When you have 1, we say it's perfectly positively correlated. Let's leave that interpretation. For example, when you want to assess whether students' study hours are positively correlated with their grades. Then tomorrow also we see Spearman rank correlation. This measures monotonic relationship between two ranked variables. For example, you want to examine whether student motivation scores are correlated with their final exam ranks. And the last one for tomorrow, where I'm going to stop for today, I'm just giving us heads on or what to see tomorrow. Like SK analysis, we have a case study on that. Then when we come to STATA and EViews, we look at cross-sectional analysis, multiple regression, time series analysis, panel data analysis, binary logistic regression, and so on. Thank you once again for your attention. Wishing us all the best.
Thank you so much, Prof.
Thank you very much. I appreciate your detailed explanations. And I believe it's going to be a good time. You're walking us through these things we've highlighted. So at this point, ladies and gentlemen, we want to take a little break and take our group photographs. We'll move downstairs right away, take the group photographs, and then we'll convene right after that to go into the next session.
So let's go down the same stretch a bit, take pictures and come back. And if we do so well, you can release us before 4 o'clock.
Yes.
Perfect. It's doable. Because the next major one is installation of the software. We can conclude today's session before 4.
Yes, because they are very busy people here. So
I think our team, let them go ahead with installation. Is doable. We'll conclude earlier, before 4.
Okay, so let's come back. We make sure we will now walk us through the software. So we can start to close at our people.
Correct, ma'am. Correct.
So those of us who like book, we will stay and be practicing. Those of you who want to go to the office and do something, you can do. In the night, do not continue. Is that not so? Yes. Let's stand up and go and take pictures and come back. So,
All right, Prof, thank you very much for that presentation.
All right. Thank you, Dr. Moa. Thank you. Bye for now.
Are you going to now take a little sleep before you continue?
Yes, ma'am. Yes, I'm going to. I need it. Thank you, ma'am. Thank you, ma'am. We really appreciate you, ma'am. All right, now, Dr. Moa, we can hand the Zoom. So every other thing, we don't need Zoom again for today.
All right, well, thank you very much.
God bless. Thank you. Bye.